So far, we've ignored air resistance and friction in our discussions on motion and forces. It's now time to introduce friction, as friction is present in almost all practical applications of Newton's laws. It is friction that enables our cars to propel forward, allowing us to journey from one place to another. It enables us to be able to walk or run. Sometimes we want friction to be present, and sometimes we don't. So what is it? Friction occurs when one surface slides across another. The resistance to that sliding motion is called friction. It is an indicator of how easily or smoothly the two surfaces slide. Smooth surfaces have less friction, whereas rough surfaces have more friction. The following animation illustrates how friction works. Consider two books in contact with each other, and one book slides over the other. At the microscopic level, all surfaces have some degree of roughness. This roughness causes resistance between the surfaces as they slide across each other. This resistance opposes the sliding motion, so creates a negative force against the motion. Friction is a reactive force and only occurs when there is an applied force acting to try to move one object over another. Consider a 50 kilogram box sitting on a rough horizontal ground. A person applies a horizontal force of 50 newtons to try to push the box to the right. If the box doesn't move, then there must be a force acting to the left to oppose the applied force, such that the net force along the ground is zero. This force is due to friction. Now if you increase the applied force to 100 newtons, 150 newtons, 200 newtons, and 250 newtons, and the box still doesn't move, then this implies that the frictional force is increasing proportionally to oppose the increased applied force. Applied of the frictional force versus the applied force shows a linear relationship. As the applied force increases, the frictional force increases by the same value such that the net force on the box is zero. This is until it reaches a maximum value before the frictional force drops, then becomes constant. At this point, any increase in the applied force results in an increase in the net force and thus an increase in acceleration. The box starts to increase in speed. If you remove the applied force, the box will begin to slow down and eventually come to a rest. When we look at the frictional force graph in detail, we see that there are two distinct regions. The first is a region where the frictional force increases linearly with the applied force to some maximum value. In this region, the box is still stationary and the frictional force is being applied to the extent that it is equal to and balances out the applied force, so the net force is zero. This region is a region of static friction. There is a maximum value of the static friction, which is the threshold in which friction can prevent motion. After this point, the frictional force is no longer able to match the applied force and the mass begins to move. In this example, the threshold occurs at 250 newtons of the applied force. The threshold of static friction is measured with a parameter called the coefficient of static friction, which has the symbol of the Greek letter mu and a subscript s. The coefficient is a value between 0 and 1 and represents the ratio of the maximum static frictional force to the normal force that gravity exerts on the mass. Since it is a ratio of two forces, then the coefficient is dimensionless. For this example, the box has a mass of 50 kilograms. So what is the normal force that the ground exerts on the box? The normal force here is 490 newtons. Since the maximum frictional force is approximately 250 newtons, then what is the coefficient of static friction? In the second region, the threshold force has been exceeded by the applied force and the box begins to move. Friction acting in this region is called kinetic friction. In this region, the frictional force is approximately constant, but is less than the static threshold force. So once a mass begins to move, it is generally easier to keep it moving across the surface than to start it moving from rest. The frictional force is characterized by the coefficient of kinetic friction, mu with a subscript k. Mu k also has a value between 0 and 1, but is always less than mu s. Mu k represents a ratio of the maximum kinetic frictional force to the normal force that gravity exerts on the mass. In this example, the kinetic friction force is reduced to 188 newtons. So what is the coefficient of kinetic friction? Remember that the box has a mass of 50 kilograms. Once the applied force exceeds the maximum static frictional force, the object will begin to accelerate with the net force being equal to the difference between the applied force and the kinetic frictional force. As the applied force increases, the acceleration linearly proportionally increases, as shown by the blue points and the blue line on the graph. You notice that the acceleration does not begin at zero when the threshold force is reached, but rather at some value. In this example, that value is 1.2 meters per second squared, as shown by the black dot. There is a third region, which is within the static friction region, where the static friction exceeds the kinetic friction. Even though the static friction is higher in this region, the applied force must still be greater than the maximum static frictional force in order for the mass to start moving from rest. However, when the mass is already moving, then the threshold force needed to keep the mass moving is reduced. So in this example, the applied force needs to exceed 250 newtons to start the box moving, but only needs to be 188 newtons to keep the box moving. In summary, there are two main types of friction: static friction and kinetic friction. Static friction acts to prevent a stationary mass from moving, while kinetic friction minimizes the motion when the mass is already moving. Static friction is characterized by the minimum value needed to start the mass moving from rest and is measured using the coefficient of static friction, μs. μs is a ratio of the maximum static friction to the normal force. So the maximum static friction can be given as μs times the normal force. Similarly, kinetic friction is characterized by the minimum value needed to keep the mass moving and is measured using the coefficient of kinetic friction, μk. μk is a ratio of the maximum kinetic friction to the normal force. So the maximum kinetic friction can be given by μk times the normal force. Static friction is reactive and is equal to the applied force while the mass is at rest, while kinetic friction is constant while the mass is moving. Kinetic friction is always less than the maximum static friction. The animation used in this video was made available from the PhET Interactive Animations project at the University of Colorado. You can open the animation by clicking the animation link in this module within Video Collaborate. I would encourage you to play with the animations to be more familiar with the force concepts.